We need to divide the polynomials using the box method. We need to note that we are effectively performing division as follows. So we are dividing a 30-degree polynomial by a second-degree polynomial, getting a linear degree polynomial. Linear degree quotient. So a quotient of degree 1, which is of the form ax plus b. And hence now we actually will be able to get the quotient at the top, ax plus b, or of the form ax plus b. And therefore here, this block is the remainder block. Right, so we note a couple of things. That is, we are doing the division here. The denominator has a specific name called the divisor. And the top is called the dividend. Is called the dividend. So with that said, then we're able to perform division as follows. Okay, so how to perform the division? We actually realize that the divisor is actually twice x squared, but there's a missing linear term there, the 0x term in the last one, which is the constant term. Constant term. Okay, right. We have 4x cubed, the leading, the coefficients with the term with the highest degree. Right, 4x cubed. And obviously it occurs in the numerator, and therefore we write it down first. And we divide 4x cubed by 2x squared, and what we get is twice x. Right, in which case, therefore, we multiply 0x times 2x, we get 0x squared minus 1 by 2x minus twice x, like so. Okay, right. Now we further do an examination and realize that we look at the diagonal terms. The diagonal terms like this. So this will be the x squared terms, x squared terms. So we have minus 2x squared. What we add to 0x squared to get minus 2x squared. So we get minus 2x squared, like so. Right, because when we add the 0x squared with the minus 2x squared, we get minus 2x squared. So, but also now we are actually certain of these. So what do we then do next? We perform division. So minus 2x squared divided by 2x squared gives us minus 1. And we multiply 0x by minus 1, we get minus 0x. We multiply minus 1 by minus 1, we get a 1 there. Okay. What then is the next thing to do? We actually look obviously at the next set of terms. So we actually now need to look at the diagonal terms here with this one. Obviously, we can realize that we have no linear term there, but it is diagonal terms now. Here it's minus 2x minus 0x. And now the term that must be added here is twice x, so that we have 0x in the numerator. Okay. Right, with that said, then we are here. And we then obviously look at these and think very carefully. Are we done? Oh, well, we are not done yet. We have just taken care of the diagonal terms there. We need to take care of the further diagonal terms, meaning at this point now, the diagonal term here is a constant, and therefore, obviously, it must be dealt with the constant there. What do we add to 1 to get minus 3 is a minus 4. Minus 4. So we have this. Okay. So we have the remainder. So we have 4x squared. 4x cubed, excuse me. 4x cubed minus twice x squared. Minus 3. You divide that by twice x squared. Minus 1. And if you divide these, we get a quotient. And the quotient is twice x minus 1. And then now we'll get the quotient seated at the top of the box. And now we have the remainder. What is the remainder? The remainder obviously is twice x minus 4. And it is most certainly divided by the divisor. And the divisor is actually twice x squared minus 1. Okay. The box method has a wide range of names. Some people call it many things. And so at this point, all right. So at this point, some people call it the um they call it the area model, area area model, area model. And some people call it, for example, the generic rectangle method, generic rectangle method. Okay, some people call it a generic rectangle method, and some people call it the area model, but obviously it's also called the box model. So we used it now to actually perform division to divide a cubic polynomial by a quadratic polynomial. So yeah, we are sorted, and this is the result. Okay, and thanks everybody. Goodbye to you.